In today's lesson, and in this set of lessons, we're talking about proofing one more time, this time using algebraic reasoning and less geometry. So on the board behind me right now, we have a linear expression, a linear equation, if you will, with the equal sign. On this half, we have a linear equation in the form a times the quantity x minus b. Over here, we have a line cx. Currently, we have these two lines equal to each other. Hopefully from previous studies, you remember that when lines that are equal to each other, they will intersect at a given point. The intersection point is our solution to a system of equations. In this setup, algebraically, we're just going to be solving for x, an unknown variable. And when we see an expression like this, the a's, the b's, and the c's all represent some other constant. So we're looking at two linear expressions in this format. We're going to first look at an example to see how we solve these. We're going to talk mostly about the properties that are involved to show that these are in fact equal and what we need to do in order to solve them. So we'll start with this expression. On this side, we have a 2 times x minus b. And so we want to simplify this to a point where we can collect all of our x's on one side and all of our non-x terms on the other of the equation sign when I refer to other sides. So we're going to multiply this 2 inside of the parentheses. That's called the distributive property of multiplication over, in this case, subtraction, but it could also be over addition. So we're going to distribute the 2 here and distribute the 2 there. I use the arrows to help remember where I'm multiplying. 2 times x is 2x, and 2 times a negative 8 is a negative 16. That is still equal to 4x that's on the right of this equation. That's the first step, using the distributive property of multiplication. Next, we're going to take a look at a property that allows us to combine the x's. We're going to move this 2x to this side of the equality, the equation. To do that, we have to use properties of equality. And one of those properties is called the subtraction property of equality. We would like to remove this positive 2x by doing the opposite, subtracting 2x here and subtracting 2x there. That is the subtraction property of equality. We subtract the same things from both sides of the equal sign. 2x minus 2x is 0x's. I'm not going to write 0x. We're just going to leave it off. But I am going to carry down this negative 16. On this side of the equation, 4x minus 2x, these are both like terms. 4x minus 2x, I can take this, subtract, and get 2x. In terms of the properties that allow us to do that, another way to write this is to write 4x minus 2x. X is in both. I could then do factoring process to say that this is really x times the quantity 4 minus 2. It's a reverse of the distributive property. That's the algebra that goes into this kind of mathematics. We know the shortcut then is to just subtract 4x minus 2x to get 2x. The algebra here would show that we have to factor out the x. 4 minus 2 is 2. X times 2. We like to put the numbers as coefficients, so this returns as 2x. Lastly, we want to make sure that we're solving for x by undoing this division problem we see here. So we divide by 2 here, and we divide by 2 here. That is done through a division property of equality. It's on both sides of the equal sign. We divided the same thing on both sides. Negative 16 divided by 2 is our negative 8. And we have our solution. X equals a negative 8.